Hey guys, so today we're going to be going over a problem that involves circuits, and particularly we are going to be focusing on the equivalent resistance and finding the EMF when given the equivalent resistance and the power. So the first thing you want to do when approaching a problem like this is my advice to students that I've worked with previously is to always redraw the circuit in a way that's most comfortable for you. And not only redraw the circuit starting off with, but as you'll see, just to give you a quick illustration, redraw the circuit every single time you do a step. And we'll go over this. But just to start with, for a brief, quick summary or intro, whenever you're dealing with resistance, you want to remind yourself of the formulas that are involved with resistance, meaning the series and parallel. So as I drew highlighted in yellow, when you're dealing with a series and the resistors involved in a series, the equivalent resistance is simply just the sum of all the resistors. And then when you're dealing with a parallel circuit and the resistors, it's also the sum. However, everything is 1 over, as you've seen that I drew. And on the left of it, I simply just drew what is what, right? So on top, you have the series, and on bottom, you have the parallel. So whenever you approach a circuit problem, even if the resistor values are given to you in the word problem, my advice is just to write every value next to it, next to the circuit. It just makes it easier to recall whenever you're doing the calculations. So now starting with the actual problem, I have the circuit drawn as it was originally given by the student. And then the first thing that you want to do is you want to find essentially the first step. You want to find the first step that you want to calculate and then go from there, right? So the first thing that I did was I found that there's a parallel circuit within right on top that I highlighted, and I simply just calculated it, right? So I did the math, and then I found that it is equal to 3.33 ohms. And then I redrew it, right? You see how it went from a parallel circuit to a series circuit, right? Because I turned it into a resistor with equivalent resistance. Okay, which is something that you can do, and I uh, really exaggerate how important it is to remember that you could draw resistors as another resistor with equivalent resistance. So now that I made this change, I have these two resistors that I highlighted that are now in series. So, and the reason why it's important to approach these two resistors in series before any other step is because I can't do any further calculations. Like I can't do any other thing before I do this. So I found the total resistance of what I highlighted. And since this is a series circuit, I simply just found the sum, right? Which was 7.33 ohms. And this answer is, keep in mind, it's the equivalent resistance of resistor 2, resistor 3, and resistor 4. So I now redrew it again. And this time, those two resistors that I drew, that I highlighted right here, it is now illustrated as one resistor, right? And now that I have a parallel circuit, I'm now going to do the math for two parallel resistors. And when I did the calculations, as I highlighted on the right, I ended up getting 2.13 ohms. So one thing that I actually should have mentioned in the beginning was that there's a formula right here on the right. And I think that this is something that's really important, that whenever you're working with parallel circuits, like the resistors in particular, you could use that formula that I drew on the right. And it can help you find the equivalent resistance for two resistors that are in parallel, as I've done right here. because it's simply just the two resistors right here on the top and bottom. As you can see, 7.33 times 3, and then divided by 7.33 plus 3, which equals 2.13. So then moving on, I have those resistors that were in parallel now being illustrated as a new resistor as a series with R1, right? So remember, when you're working with series resistors, you're just you're just finding the sum. So you're going to have 3 ohms plus the 2.13 ohms, which we calculated previously, and that adds up to 5.13 ohms. And just to redraw it, this circuit right here in step 5 is completely equivalent to this whole circuit that we started off with, right? I think this is pretty cool in my opinion. So you just want to understand how important equivalent resistors are and understand the process between every step. I really recommend in general, when you practice physics in general, regardless of circuits or not, you want to really take your time with every step, because when it finally comes to the exam, it will be very easy for you because you'll be used to doing all the calculations and all the drawing. So then for part B, he was asking us to find the EMF of the battery, as you could see right there. So they told us the power, which was 4 watts. And the generic formula when you're dealing with voltage and power and resistance is power equals V2 over R. But in this case, it's the E symbol, right? So that's why I substituted it right here. So I simply just multiplied both sides by R. So I have R, I should have written this, R equivalent. So you have E equals the square root of REQ multiplied by power. And we know from before that REQ is 5.13 ohms, and the power is given in the problem, which is 4 watts. And then that multiplies to 20.52, and the square root of that is 4.53 volts. So the EMF of the battery is 4.53 volts. So I hope that helps with this problem. And if you guys have any questions or any recommendations on how I should approach problems or draw things, please let me know. Thank you, guys.